I'd like for you to go on a journey with me. Picture yourself in your office. I'm sure it's like mine, the corner one at the top of the building in downtown where it overlooks the glistening water. And while you're in your office, your boss comes in and says, I've got great news. We have a new employee. They're going to be joining you here soon. They are amazing. They do work so quickly. They have PhD level intellect. They're going to help you meet all of your numbers next quarter. And you say, wow, that's amazing. When can I meet this person? They go, well, uh, there's one little thing here. Um, they have the memory of a 6 year old. No offense to 6 year olds. And you say, oh, okay, well, that's going to be a little bit different. So how do I work with this? And essentially that's where we're at today. We have these amazing systems that have proven themselves to be able to do incredible things, but in terms of memory, they don't really have any memory at all. And any memory that does exist is through what the developer or the framework developer has decided to give it in terms of memory by what they put in the context window. And we have this asking ourselves, is this the AI that's going to lead the revolution? Well, I do think it's already creating some major change and disruptions, but I do think that what we will see in the future, I think memory will play a role in how it evolves. All right. I want to take you back to November when Sam Altman posted, There is no wall. And you know why Sam posted this? Because there was a wall. And the wall that we're talking about here was that the pre-training wall. So this is what gave us LLMs and their ability today is the intersection of compute and the amazing technology from those folks at like NVIDIA that gave us this ability combined with our access to data and the bright minds and the sharing of the academic research that created this scaling effect where LLMs got smarter and smarter the more data that we threw at them. And that led us to where we are with this amazing coding ability and content creation logic that is, unlike anything we've ever seen. When I was a developer working in the simulation industry, and I remember the first time I created terrain, and I was like, I made Earth, I made terrain. I had the very same feeling when I did my first prompt with an API and heard the system talk back to me. And so it's quite amazing what we've been able to do so far. But I think there's a lot left to go. And what we have now is this automation capability. And it's part of these walls that are creating barriers. So we were able to get around the pre-training diminishing returns by introducing reasoning models. And the reasoning model takes your prompt and basically expands it so that it's writing a more thoughtful prompt that allows the system to think through the steps that it takes to achieve a job. And when they did this, they saw that the systems were able to achieve and beat benchmarks that they were unable to before. And this helped us achieve and get over the wall of pre-training alone. And also, we've done this with more iterations through agentic capabilities. So, the idea that you might do some processing on a smaller amount of context and then save those results and then do it again. And this is also, in this iterative form, also is able to achieve better results. And still, though, I believe that when we get into this iteration, this is where the role of a well defined memory architecture is going to take things to the next level as we save the state and save the information in between the iterative runs. So, are we at a wall now? There could be some form of a wall, but I do believe that memory is going to play a big role in our next capability, a system that knows and understands us, a system that can achieve higher order thinking, not just remembering and understanding, but analysis and, getting closer to doing primary research. A system that learns and grows and beyond what its pre-training information is, and a system that moves from automation to imagination or innovation. I think memory will play a role. All right, let's give Sam his flowers real quick, though, because Sam did say when memory came out in ChatGPT that he said that that was his favorite feature. So let's give Sam his due. All right, so moving on. A lot of times people will ask me why we need a memory system if we have such large and growing context windows. So, when we first all started a couple of years ago, we had very small context windows, and it wasn't too uncommon to run up against them and realize that you have to do something to pare back the information so that it wouldn't exceed the context window. But since then, context windows have grown, and both Google and OpenAI have increased, and Anthropic have all increased their context windows, and the biggest now is up to 10 million from Meta and what they've done with Llama 3. But if a context window is 1 million tokens and can hold 9.75 Harry Potter and the Sorcerer's Stones, then why do we need memory? And the reason is because it's not that simple. It's not just about fitting the information. The relationship here is that as context window usage increases and as complexity increases, we see LLM performance decrease. And I have 4 charts here that show various degradations in performance based on different attributes of the context window. The first one being a focused or a full context window. So think of this as high signal to noise ratio, and a focused context window performs better than one that is full of information. The chart 1 and chart 3 are from Chroma's latest research. Chart 2 here is from LangChain, built upon some other great work from Greg Comrade. Talking about the number of needles. So we have all heard of needles in a haystack. This is multiple needles. And as the number of needles increase within a static size of a context, we see that performance degrades as well. So number 3 is about distractors. And as the number of distractors increase, we see performance decrease. So a distractor is like the answer to the prompt, but it's not quite right. And it's even shown that the bigger of a distraction, meaning the closer but less correct a distractor is, it has a bigger impact on the hit and performance. And then lastly, number 4 is about with a very small amount of context, we can see that the complexity can play a role. So this is complexity represented by a dependent chain. So the results of a small algorithm, less than 300 tokens, where answer C is dependent on answer B and answer B is dependent on answer A, that defines the number of jumps. And the number of jumps, as they increase, we see the LLM's ability to accurately achieve those results of the algorithm decrease. So again, it's another factor of complexity. So I have these here for you. And these are all great and interesting. And I invite you to dive a little bit deeper. Number 4 was an experiment that I did directly myself. Okay. Expectations for a genuine conversation. I think memory plays a role in what we expect from our interactions with an LLM. So for example, what if you and I were talking and you told me a phone number? What was your expectation of me remembering that phone number in 5 minutes? Well, I might be able to get most of the digits, might not be able to get all of them, but certainly I remembered that we talked about phone number. And certainly in the past hour, I think that you would expect that I would remember that we had a conversation about phone numbers. But what about a week? What about a month? My wife, for example, might be more tolerant because I have a tendency to forget things that we talked about yesterday. But from person to person, maybe there is some variance. But where is this idea that there's, a lifetime to these memories? And, these maybe not anything past the past hour, maybe not the week long and the month long, but these shorter durations are what we call working memory. It's what we store in the short term that's very relevant and very ephemeral. So those are working memories, a big category of memories that we're going to talk about. And then the others here, I have like the other person understanding you and knowing who you are, your likes and dislikes, your family or your career possibly. Those are all long-term memories. So might be a worldview. People who are from the same area or have similar backgrounds might have similar semantic worldviews. And these are just a few examples of long-term memory. So that's our first type of abstraction here, which is working memories and long-term memories. Let's dive into working a little bit more. I've seen lots of different references to working memory in the literature, and you'll find a variable set of answers for what people consider working memory. As extreme as I've seen the KV cache be considered working memory. The KV cache is an optimization result of how we can save on computations of the tensors during the response. To me, that's not working memory. That's not part of our conversation. It's a performance optimization trick. So no, I don't see that as working memory just because we've saved it. Fine tuning is very similar. It changes the way that information is kind of presented and influenced on the response. Not working memory in my mind, but response history, that makes sense. And I say response, I mean response and input as well. So as the log of a previous conversation, is inserted into the prompt, into the context window, that response history can play a role as working memory. But as I mentioned earlier about having full context windows, I think of it as a budget that you're eating into by just putting the full log. So maybe you want to do something more complicated, like saving a summary of that log. And so some systems do that and call that working memory. Other systems, and something I'm going to show you a demo of, is this idea of a working memory state, where it's like a register of variables about the conversation, where certain variables may hold for a very long time and others may be more ephemeral. And those are combined into a concept of a working state. So let's take a look at that through an example. So in the system that I'm building, when you talk to it, it can visualize the conversation if it's something that makes sense to be visualized. So if you play a game of tic-tac-toe, it'll render it, and so you can visually see it. And I've stopped it in the middle of the game here. I took my turn and the system took its turn. And let's observe what working memory looks like in our observation system now. So it stores the user intent. And user intent is not the same as a user prompt, because we kind of like don't always say what we mean, right? If I say something like, what is that? Right? I might have to look at the history of our conversation to understand what that is a reference to. If I'm just thinking in isolation, that is unclear and ambiguous. So user intent is this idea of what the user is trying to say, both within the historical concept of the recent conversation. And then the state of the conversation is, stored here in this JSON type of memory. And the working memory steps 1 through 4 are really just about implementation of how basically a chain of thought of breaking the work into steps, because it's a bit complicated and hard to do with one pass to go straight to step 4. So then step 4 is the ultimate output, which is the difference in state from the last turn to this turn in the conversation. And it's good for you to use multiple types of systems. I have this working memory state, but I also have a response history log that is saved in the short term in case you want to reference the thing that you said in the last statement, or what is that thing in that table, might not be something you want to store in working memory that you can easily store in response history. All right, personalization. So let's dive a little bit into this. We mentioned that this was a form of long-term memory. So I think it's important, especially if your application is really focused on relationships, that you're going to want to have personalization play a really big role in your memory system. And some memory systems are entirely focused on this aspect, where they kind of cherry pick and listen to the conversation and pick information about the user's preferences out of the system, and then store that, keep them in a log or a profile. In the holistic theory of mind, which Sam Whitmore discussed at her recent meetup in San Francisco, where there was an AI memory meetup, she discussed the holistic theory of mind, which saves this dossier, this profile of the user with the family, career, interests, and whatnot. And this is all something that would play a role in making a more personalized experience. All right, let's dive into long-term memories more. That's just one example, and where a lot of the memory systems started is this idea of trying to create a more personalized experience. So 2 concepts here. Let's talk about the first one, is just the unit of a memory. Most memory systems have some kind of chunk or cube or memory block or something along those lines. And there's some similar characteristics between them. In my mind, you've got the content that you're actually saving. This is the literal information that you think is unique, the thought, if you will. And but then it also should have a context wrapped around it. So imagine if your content said something along the lines of, she had gorgeous flowing hair that would blow in the wind. And then you realize that context surrounding that is, that this sits within a larger story about a dog, right? And it wasn't, you might have been led to believe that the long flowing hair was a woman, but the additional context that you have now told you and redefined semantically what it was that you thought you were reading within that little section. So that's the concept of context, and I think context adds a lot and is very important in terms of a memory system. I think a timestamp is also something that's really important. Memories do play a role over time. So if I have a memory, imagine the set of memories that says, I like yellow, I like green, I like yellow. All right. The information we have there is if someone said, what color do you like? The information could say that you liked yellow. And that was it, as if you updated those memories. But if you choose to save them all over time, you might give a response like, well, you like yellow now, but previously liked, what did I say, green? The whatever color I said, the different order could play a role in an audit, and so having that timestamp makes that possible. So that's an important concept, I believe, in the unit of a memory. You might also have some type of meta capability for filtering, again, trying to be as efficient as possible of how we load information into the context window. Now, onto the right side of the page. We got episodic memory, we've got semantic memory, and procedural. Episodes being the events, the semantic being the relationships of our worldview, and procedural being skills and habits. Just touch on this for a brief second. The reason these all come from neuroscience and cognitive psychology and different types of neuroscience. And the reason that we believe that they are separate yet overlapped is that certain afflictions will affect certain parts of your memory system without affecting the others. So, for example, someone with amnesia might have trouble recalling certain events during certain periods of their life, and they might even have missing pieces about their semantic memory, but then they can brush their teeth or they know how to, do everyday tasks. So one portion of the memory was less affected than the others. And there are several afflictions that affect certain parts of memory. So this is part of how we classify and discuss and understand memory. And it just seems natural for us to look to how we think as a guiding star for how we develop our systems in AI. So it's kind of become part of the vernacular for AI memory. All right, whereas long-term memory, it's basically getting fetched by retrieval, and that could come in lots of different forms, and people will call different things long-term memory. Some people will call a database that they might store information long-term memory. They might store key values or something like that as a memory system. They'll call that long-term memory. I saw someone call an embedding long-term memory. I think this is kind of similar to the KV cache, calling that long-term memory. I don't agree with that. I get the concept that they're related, but I wouldn't consider that long-term memory. Some people will say, I have long-term memory because I have a vector database. And, I think that's true. It is storing of information, but I think it gets a little more specific. And, graph, I think, is another one that I hear frequently, especially with the concept of semantic memory. They'll say, I have semantic memory that's managed by my graph database. And then I think ultimately we're kind of converging along this idea of these different memory types, and their implementations are not always distinct in the same way that the different memory types are individual but yet overlapping. I think implementations of these memory types will also mimic that as well. All right, moving on to episodic. So, episodic memory is something like an episode from your past. So, the classic example would be a birthday, but I really prefer the mental time travel example. The idea that you can go back in time to when that episode happened and you can put yourself in that place. You might remember smell or an emotion or other details, and the event itself might not be a huge life-changing moment in time like a birthday, but it could be a meaningful conversation that you remember. I really like this idea too of memory consolidation. So I added that on here as well. And I don't think this is necessarily specific to episodic. However, I do think that the idea that some memories might be more ephemeral and recent, and then as we ponder over them or we sleep at night, we might consolidate these into more durable, long lasting memories. And I think that episodic memories in particular are something that we could accumulate quite quickly within our systems, and having some type of pruning consolidation system will help create a more efficient memory architecture. All right, so just a quick example of what this might look like. So in my tool, when you are having a conversation, it has the ability to continue to play and record memories, but I'm instead kind of starting with the ability for users to select and choose when they're creating a memory. So you click that little square there, which saves the memory in the background. And once you have that, then you could say reference it and have a conversation about the tic tac game board that you just had. Will bring up the opportunity for you to have a reference that you could then click on, and this actually shows you exactly what the long-term memory looks like. You can see that it's got the information inside the long-term memory, but it's also adding context and saying that it's a game and the players move, and then also the timestamp that we mentioned earlier. All right, on to semantic memory. So from this block of text here, I was able to extract and demonstrate what a graph might do. So there's an entity node like dog and path and thing here. Those are all entities. And the dog has a relationship with the path because the dog is walking down the path, and the path has a relationship with the dog because the path has a dog on it. And similarly, we have the dog relationship to a thing that is found, and then the thing is being observed by the dog. And this is how a semantic memory system works. We're building this relationship driven graph. So you build the graph, and then with the graph database, you're able to query it and then take that information from the query and add that to the context window, adding all of the relationships and additional context in semantic memory. So, one thing to keep in mind with this graph, you have to update it because it's a part of your worldview and it's evolving and changing. So, this concept of it being a thing, we'll have to update that when the thing is discovered. So let's say that the thing is now discovered to be a bone. And so within this graph, we would either have to add a new entity that says there's a relationship between the dog and the bone, and you could replace thing with bone. Or if you wanted to, you could even keep the thing and then update and maybe say that it's an invalid relationship. And so you still have the historical record so that you can audit and show that the thing was a thing and then became a bone. So that's some of the challenge and implementation details to work through when using something like a graph to represent your semantic memory. All right. Procedural memory. This is one that is not explicitly defined in a lot of our systems, but you might be able to still implement a procedural type memory anyways. So it's a skill or a thing. It could be something like maybe a 1, 2, 3 type of list of giving you actions. Some people will think of a procedural memory like when you have a system that is controlling and checking in code, and it calls the external code to create a pull request. That could be considered maybe something triggering a procedural memory that triggers an external tool or a skill or a capability. Inside of my system, you can load these procedural memories when the server starts. So there kind of is a base capability of the technology, are these procedural skills. And everything that defines what can be done in this task or skill is defined in this memory. And there's a little rendering instructions or rendering primitives that it is aware of. And so when the memory is triggered, it'll follow the rules, and it will also display the rendering primitives. And then on the client side, there's it'll recognize the rendering primitives and add, in this case, it is a sticky note type pad that will be displayed and can be saved along a conversation or a topic. So this is an example of a procedural memory that is explicitly defined in the system that I'm working on. Okay, so let's put it all together. I have my prompt, and the prompt is then going to be analyzed. This is where the short term memory might get updated, and the short term memory would be then available for the context window. It might also be available for the retrieval system to understand. Certainly, something like the user intent would play a role. And the system that I've built I call it a memory native. So all of the information that it's fetching is from the memory system. So everything's a memory, including the procedural memories that were created during the creation or the startup of the server. The source documents were scanned into memory structures. The training, which occurs based on the knowledge of the source documents, which is where the system creates abstractions and refines and kind of consolidates memories during the training phase. And then maybe I have some conversations, and I don't have it listed here, but you could have also some semantic memories that might be fetched as well as part of the retrieval. That information is all combined into the context window with the system memory, inference is run, and then the output is delivered to the user in the form of a chart and a graph and maybe some text as well. There's a lot more to grow on with this. We aren't done. This is just the beginning of AI memory. I like to think about the temporal nature of memory. Should it fade like humans? Some systems are very particular about whether or not the memory is saved asynchronously or synchronously within the conversation path. And there's different implications for that depending on the system that you're using. Um, there's been a lot of conversation about people wanting to own their memories with their own identity so that if I switch from one tool to another, so maybe there'll be a unified protocol, unified standard for memory. And then deleting, updating, and validating memory is its own talk on its own. It's pretty complicated because it can be hard to update a memory. You might end up updating the wrong memory. Do we really want to delete memories? Our mind doesn't really work that way. We kind of add more memories and then other memories are suppressed to some extent. And then I put in versions here. It's just another unique problem that I've dealt with where we might create memories across things that are intended to be in different versions. And without that context and version being included, you can end up commingling information across versions. So lots to think of. There are vendors out here, and there are probably many more than these that I'm not familiar with. Some of these are a little bit more on the research side, and they offer open source for you to learn from. Some of them are commercial products that are SOC 2 compliant and production ready today. So what I've tried to do here is just kind of mark them based on, it's kind of a combination of their marketing, or when I look through their examples of what they're really focusing on in terms of a capability. Some of these definitions are a little fluid between episodic and semantic and procedural in terms of implementation. So someone might have an implementation that's very focused on semantic, but you could maybe use it with episodic type memories or maybe procedural. So nothing here is hard and fast. This is just a little bit more about kind of the angle or the lens from which the different frameworks view the world. So explore and discover them on your own. I encourage you to. All right. Well, that's the end. I hope you learned something. And I know every day I'm learning things, and I hope to look back at this video in a year from now and say, wow, we knew so little and we learned so much. It's a very dynamic space. It's evolving quickly. And we're really in that early conceptual phase where definitions aren't even standardized yet. But it's a great time to get involved, to get into it and get involved and really help be a pioneer in this space. So I hope you learned something, and I hope you take this and run with it and build something great on top of it. And I can't wait to be inspired and awed by something that you've built, hopefully with this as a little bit of influence towards making something great. Thanks again for your time. I'm available for consulting, speaking, vendor evaluation, strategy discussions. Just reach out to me. Thanks.